Hey all, welcome back. Mr. Noldy here with a review of the chain rule, what is called the chain rule in calculus. Actually, this will probably be one of my last calculus videos for a while. I just found out from my guidance office that there was not enough interest, believe it or not, in calculus, so we're dropping that course this year. So in any event, suppose you had a problem like this: y equals the quantity 3x minus 7 squared. Easy enough. Ordinarily what you would do is you would just multiply 3x minus 7 times 3x minus 7, multiply that out, FOIL that out, and then you could differentiate it term by term. But what if instead of being squared, we'll just add a 0 there. What if that was to the 20th power? So 3x minus 7 times 3x minus 7 times 3x minus 7, 20 times. I don't know about you, but that seems like a lot of work to me. So enter the chain rule. So the important thing about using the chain rule is that you have to identify what is the chain. So I'll do that in a different color. This is called my chain. I call this the chain. So that's my g of x in this case. So I'm going to pretend that 3x minus 7 is just another variable, and I would take the derivative. So, that's squeaky. So if this was just a variable x to the 20th, it would just become 20 times that variable, and then we would reduce this power by 1. So what's in the parentheses is still going to be our chain. We don't do anything with the chain in the first step. The last step is to multiply by the derivative of the chain. So multiply the derivative of 3x minus 7 is 3. So we'd multiply by 3. And there you have just used the chain rule to take the derivative of something that has a kind of a big exponent on it. We'd probably clean this up a little bit, I suppose, and make it be 60 times quantity 3x minus 7 to the 19th power. So there you have it. Quick example. We'll look at a couple more here, but the chain rule. Now let's look at another one. So here's the next one. Notice we have a radical here. So ordinarily, if you had a radical and it was just y was the square root of x, if we were going to take the derivative of that, we knew to change that to a fractional exponent. So y equals x to the 1/2. Then I can take the derivative using the chain or using the power rule. Right? So a similar thing is going to happen here, but the radicand is not just the x. The radicand is an entire expression, 5x squared minus 4. So the first thing we're going to do is write this as a fractional exponent. So 5x squared minus 4 to the 1/2 power. So now I can use the chain rule. Now I can pretend that this is just a variable, right? This is my chain. Write chain in there. So when I go to take the derivative, I'm just going to pretend that this is a variable. 1/2 times 1 is 1/2. Don't do anything to the chain until after you've modified the exponent. So it's still 5x squared minus 4, but reduce this exponent by 1. So it goes from 1/2 to negative 1/2. Then we're going to take the derivative of the chain right here, 5x squared minus 5, or minus 4. So that is just 10x. So if I clean this up a little bit, half of 10x is 5x. So I could say, all right, this is 5x times the quantity 5x squared minus 4 to the negative 1/2. Usually we don't have a negative exponent in the numerator, so you might see it written this way: 5x all over 5x squared minus 4. And you might even see the exponent replaced with a square root symbol. So there you have it. How to do the chain rule using when you have a radical. So looking at the next one, we have a trig function. So notice this isn't just the sine of x. If I was going to take the derivative of the sine of x, it would be cosine of x. But I have a chain in here. So this is my chain. So identifying the chain is really important. So the first thing I'm going to do is take the derivative of the sine of x. Just pretend that's x. So the derivative of sine of x would be cosine of x. So cosine of x, and my x is this 3x squared minus 4. But I'm not done yet, because at the end I have to take the derivative of the chain. So I would end up multiplying this by 6x, because the derivative of 3x squared is 6x. So cleaning it up at the end, you'd probably have 6x cosine 3x squared minus 4. And that, friends, is how we take the derivative of a trig function. I'll now show you one more trig function that can get a little bit tricky if you don't know a little bit of a trick. So let's see what that one looks like. So here we go. Now I have sine cubed of 7x. What do we do with that? Well, the trick here, what I always remind students to do, is remember that the sine cubed of 3x is the same as, or 7x is the same as the sine of 7x, the whole thing cubed. So now I can employ the chain rule here. So I'm going to pretend this is x cubed. So if it was x cubed, to take the derivative, I would say, all right, 3 times the sine of 7x squared. So we're not done yet, because I didn't do anything to the chain. So we now have to take the derivative of the chain. So the derivative of the cosine of 7x is the cosine of 7x. I'm sorry, the derivative of the sine of 7x is cosine of 7x. But I have another chain here, right? This is another chain. So I have to multiply by the derivative of the chain that's inside. So that would get multiplied by 7. So in the very end, if we clean things up here, we would have, let's see, 7 times 3, that's 21. I'd have sine of 7x squared, which is sine squared, is how you would write that. Sine squared of 7x times the cosine of 7x. I don't want this to bleed, but I'm not getting good coverage. There we go. So, or there. So 21 times sine squared 7, because I reduced the exponent from a 3 to a 2, and then just rewrote it this way. Then we took the derivative of the sine of 7x, which is the cosine of 7x, and now this is a chain, and the derivative of 7x is 7. So we have an embedded chain when this happens. So just to be careful with that. The biggest thing is a lot of times students don't realize that this is the same as this. So rewrite it, makes it easier to use the chain rule. So there you have it, 4 examples of chain rule. I'll be back next time with some pre-calculus. All right, I hope you got value out of that. If you don't mind, go ahead, like, subscribe, comment, and share with other people who you think might benefit from some of these videos. Until the next time, this is Mr. Noldy signing out.